Hi everyone, welcome to the ICCII 1603 SP and 1612 Incremental Training. This is the timing analysis part 1. This is the agenda for timing analysis part 1. Report clock timing command enhancement from 1603 SP1. Prime time and ICC can report unconstrained time passes. Therefore, using dash from, dash through, and dash to options of the report timing command on clock tree node, you can report the latency on clock paths which are unconstrained passes in the prime time and the ICC. However, the report timing command in ICCII cannot report unconstrained passes. To report latency for clock passes, the dash through option was added to the report clock timing command. With report clock timing, dash from, dash through, and dash to options, you can report the latency on clock path. Dash through option should be on direct clock passes. It will only report the worst path, which means n worst option is not supported. Support the launch, capture, setup, hold, greater than, lesser than, and dash clock options. Also, support the rise and fall options. If the rise and fall option is not given, report the latency of the endpoint triggering edge. Only support timing views, but not support synthesis views. Here is the example for report timing from FF1CP path type for clock expanded. You can see U2G and F1 and two generate clock sources and U7G here. When you do report clock timing through U2 type latency, you can see clock latency information even though this is not constrained path. However, when you do report clock timing through U7G type latency, no clock latency information here. The report clock timing command does not report clock passes traversing through pins if the pin's transitive panel is not sequential clock pins. In this case, generate clock is the final transitive panel for U7G. That's why no clock latency information is shown here. New analyze timing correlation command from 1603 SP1. Analyze timing correlation command creates an endpoint timing report for each active scenario of the current block in ICCII, and then the specified version of prime time. Analyzing the pairs of timing report, the command generates a correlation table for each scenario. The correlation metric at the default 3% threshold is prime time slack minus ICCII slack divided by prime time path length. It's lesser than 3% across all endpoints. The correlation value is the percentage of endpoint measured that meet this criteria. QR table shows the timing QR in both ICCII and prime time, along with the numbers of violating endpoints that are unique to either tool. Finally, it shows the difference between the QR measured in each tool. Here is the example. With analyzed timing correlation with prime time executable path, you can see all endpoint correlation with 3% threshold. Violating endpoint correlation with 3% threshold. Absolute slack difference on average and absolute slack different standard deviation. Also, you can see WNS, TNS, number of violating endpoint for ICCII and prime time. Please check main page for all UI options. Set sense command enhancement from 1603 SP2. New dash clock leaf option is added for set sense command. With the new clock leaf option, it will stop the clock propagation downstream. Recognize the clock getting checked in the upstream network. Set is clock used as clock attribute as true for the fan-in of the leaf pin. Here is the example. When you apply set sense dash clock leaf marks S0 with clock, the clock propagation stops at the pin marks G. It makes marks S0 as the leaf pin of the clock. Clock is considered to be consumed in the fan-in branch. This clock used as clock attribute is true in the fan-in branch, including the marks S0 pin. This clock used as clock attribute is false in the fan-out branch, including the marks G pin. Clock getting checked is inferred between marks S0 and marks D0. The dash stop propagation and the dash clock leaf options are mutually exclusive and not allowed on the same pin in the same command. If both dash stop propagation and dash clock leaf options are defined on the same pin, the last setting prevails. Several things to note are here. Dash clock leaf option is only applicable to pin object. Write script command writes out set clock sense dash clock leaf command. Write script dash format pt command writes out set sense dash start clock dash clock leaf command. Write as this command ignores set clock sense and the set sense command if they have dash clock leaf options. Incremental timing delayed factors from 1603 SP2. From 1603 SP2, you can specify incremental timing delayed factors by using the set timing delayed dash increment. The incremental timing delayed factors can be applied to the block, cell, net, and library cells. Precedence rules are same as simple delayed factors. Write as this command does not generate incremental delayed factors. However, the write script command generates incremental delayed factors. Here is the formula for the delayed factors. Simple delayed factors, the total delayed factor is base delayed factor plus incremental delayed factors. For AOCVM, total delayed factor is AOCVM guard band times AOCVM delayed plus incremental delayed. For POCVM, total delayed factor is POCVM guard band times POCVM distance delayed plus incremental delayed. User interface. Set timing rate -increment will set incremental delay factors. Currently, there is no warning for unusually large absolute values. Reset timing rate -increment. This set only for the incremental delay factors. With no option specified, all delay factors, including incremental delay factors, are removed. Report timing rate -increment will report only the incremental delay factors. Without this option, report simple delay factors. Here is the example. You specify set timing rate late 1.17. Set timing rate late -increment 0.03. Set timing rate -early 0.78. And set timing rate -early -increment 0.02. When you do report timing rate without -increment options, you will see 0.78 delayed for early and 1.17 delayed for late. With the same constraint, this time we applied report timing rate with increment option. Now you can see the incremental rate for early and late. New report timing command format for POCB analysis from 1603 SP2. From 1603 SP2, new incremental and path delay are available for the report timing -variation command. Set time POCBM use normalized reporting false will enable this enhancement. When it is true, which is the default, the previous output of the report timing -variation command is generated. The value of this application does not change the path flag. The path mean and sensitivity are also unchanged. The increment and the path columns are calculated differently based on the setting of this app option. By default, the report timing -variation command calculates the incremental delay for each cell using the slack sigma for the path. Here is the formula. Incremental delay is mean plus minus k times sigma square divided by sigma slack. K is the value of the time that POCBM corner sigma application option setting. When the enhancement is enabled, the incremental column is calculated as incremental delay is current path arrival minus previous path arrival. The path arrival time is calculated as path arrival time is mean path arrival plus minus k times sigma path arrival. When the enhancement is enabled, a statistical adjustment is added at the end of the path report to show the slack adjustment. Statistical adjustment is slack minus unadjusted slack. Unadjusted slack is required time minus arrival time. Slack is mean slack minus k times sigma slack. Data arrival time is mean arrival plus k times sigma arrival. Required time is mean required minus k times sigma required. K is the value of the time POCBM corner sigma app option setting. Again, the path slack is unchanged whether this enhancement is enabled or disabled. Here is the default and new report timing variation comparison. First of all, mean and census are same. Also, flags are same after statistical adjustment. You can see different incremental and path delay here. The set timing delay command enhancement from 1603 SP3. This feature adds dash static and dash dynamic option to the set timing delay command for the net on the design. Net delay factors are separated in two types, static and dynamic. Dynamic delay factors are applied to the delta delay, and static delay factors are applied to the non-delta delay. The total delay is dynamic net delay times delta delay plus static net delay times non-delta delay. Use set timing delay dash dynamic option to specify a delay factor for the delta delay portion of the net delay. You can use set timing delay dash static option to specify a delay factor for the non-delta delay portion of the net delay. If you omit both the static and the dynamic options, the delating factor is applied to both delta and the non-delta delays. Reset timing delay will reset the timing delay for current corner. Report timing delay will report both the dynamic and the static net delay factors. Following is the new attribute. Following new attributes are added to dynamic net delay factors on the current design. Rate rise, rate fall, early fall for the clock net delta delay factor, and rate rise, rate fall, early fall for the data net delta delay factors. Here is the example. When you specify set timing delay dash late 1.1 dash net delay dash static and set timing delay dash late 0.28 dash net delay dash dynamic. Report timing delay will display 1.1 and 0.28 separately. Dash static and dash dynamic option of the set timing delay command can only be specified with the net delay option. If not, the tool will generate error message. For example, set timing delay dash static dynamic with cell delay, you will get command 001 error message. The dynamic net delay factors are not valid with the AOCBN guard band and the POCBN guard band options. However, you can specify static net delay factors with the AOCBN guard band and POCBN guard band options. When you specify set timing delay dash late 2 dash net delay with the AOCBN guard band dash dynamic, you will see GMD001 error message here. Currently, net delay factors are only supported on design base, not for individual LEDs. Write script command supports both the dynamic and static delay factors. However, write SDH command does not write out dynamic delay factors. Dash incremental option of the set timing delay command applies to both static and dynamic net delay factors. Report timing exclude option from 1603 SP4. From 1603 SP4, exclude, rise exclude, fall exclude are added to report timing and get timing path command. When you use -exclude option, reporting exclude all data path from, through, or to the specified pin, port, net, and cell instances. If a cell instance is specified, all pins of the cells are excluded. Similarly, when you use rise exclude or fall exclude option, reporting excludes the rising or falling passes at the specified object. All these options do not apply to clock pins. Here are examples with rise exclude and fall exclude. You can see the timing report with into falling edge and into rising edge respectively. Set data check command enhancement from 1603 SP4. In previous release, you could specify a setup or hold check between any two pins or port on datanet by using the set data check command. Data checks were only allowed between objects on datanet. From 1603 SP4, you can specify a data check between any two pins or port, including pins or port on clocknet. One or both objects specified by the prompt and the two options can be on clocknet. Write script, write SDC, and write library package will write out set data check. Remove data check and reset design will remove set data check. This example shows data check between U2A and U2G. They are on clocknet. Report timing shows data check between U2A and U2G. This example shows data check is removed with remove data check. Then report timing command will show no path because you removed data check here. This is the end of ICCII 1603 SP and 1612 Incremental Training Part 1. Please check Timing Analysis Part 2. Thank you for your attending.